Hi, everybody. Benchmark Lesson 18 homework in the Succeed book, pages 205 and 206. What we're doing today is exploring these strategies that we've been using. So they're going to ask us to solve in different ways. Sometimes they'll ask us to choose a way, and we're going to need to be thinking about why we're choosing what we're choosing. All right, so starting off, it just says to do the arrow way and counting on to solve. So when they say counting on, they're saying starting with the part, count up to the whole. You can go backwards too if that's easier for you. You can count backwards. For me, it's easier to go forward. So I'm going to start with 462. Now, I'd like to get that to a friendlier number, so I'm going to add 8 because the 8 and the 2 will take us to the next 10. So that's going to give me 470. I then want to get up to the next 100 because we're working toward a 100 number. So what do I need to add to 70 to get to the next 100? Just like with ones, 7 plus 3 is 10. 7 tens plus 3 tens is 10 tens, which is the next 100. So I'm going to add 30. That'll give me 500. And then how much more do I need to get from 500 to 700? I'm going to add 200 more. I almost don't have room. If you need to, you can swing back, just like when we're writing a sentence. You'd go across, and then you'd start back over here and go across if you need more space. But okay, so now I've gotten to 700, but I still don't know what 700 minus 462 is. Now I need to add up these parts that I put it separately. So we have 200 plus 30, 230 plus 8, 238 is the other part there. I'm going to do the same thing here with 900. Oopsie, not starting with the 9. Starting with 232. Okay. Again, I'm going to look for easier numbers. So I'm going to add 8 again. That'll get me to the next 10. So I'll have 240. And then again, we're working to an even 100. So to get to the next 100, what do I need to add to 4 tens to get 10 tens? Good. 6 tens are 60, and that's going to take me to 300. How can I get from 300 to 900? How much more is that? You can count up if you need to. 300, 400, 500, 600, 700, 800, 900. So I am adding in 600 to get there. And again, now I need to add up those parts to know the difference. 668. So 900 minus 232 is 668. On this one, they want us to do vertical form and place value in chips. So I'm going to write it my vertical form first. 907 minus 467, making sure I lined everything up. And I'm going to draw my place value chart over here. Hundreds, tens, and ones. And I'm going to represent 907. I don't need to represent both because I'm not putting them together. This is coming out of the top number. So I'm going to represent 907. That's 9 in the hundreds place. 0 tens. Always watch out for those zeros. You don't put the number in the wrong place. 7 ones. So can I take 7 away from 7? I can. Can I take 6 away from 0? I cannot. Where can I get some more 10s? I'm going to reach over here to my hundreds, decompose or unbundle one of those hundreds and turn it into 10 tens. So I still have 907, right? I have 90 here and another 10 here. That's 100 and then 7 ones. But now it's easier for me to subtract. I need to change this to represent what I've got over here. I don't have 9 hundreds anymore. I have 8. And I don't have 0 tens. I have 10 tens. And I do still have 7 ones. So now I'm ready to subtract. 7 minus 7, 0. 10 minus 6, I'm going to take away any 6. How many are left? 4. And then 8 minus 4 is 4. So 907 minus 467 equals 440. And we could add those two parts back together to check our answer. Let's do the same thing here, starting off with our vertical form. 803 minus 667. As I look at those, I'm going to need to unbundle. I don't have enough ones or enough tens. So let's see, we've got 8 hundreds, no tens, and 3 ones. It says rename in one step. What they mean is I'm going to take that 100, unbundle it, and make it 10 tens. And then unbundle a 10 and make it 10 ones. Coming back over here, I have 7 hundreds, I have 9 tens, and I have 10 and 3, 13 ones. Now I can subtract. I'm going to take away 3, 4, 5, 6, 7. 13 minus 7 is 6. Here I have 9 and I need to take away 6. So I'm going to take away 5 and 6. How many are left there? 3. I have 7. I'm going to take away 6. So 5 and 1 more leaves just 100 left. 803 minus 667 equals 136. If I add the two parts, 667 and 136 together, I will get 803. Good. This next one is a little different. Now they say choose a strategy. Choose a strategy and then explain why you chose that strategy. So I'm looking at this. There are lots of ways I could do it. I could do it vertically with the chips and a place value chart. I could use the arrow way, but I could also use compensation. Can you see a good reason to use compensation here? I have 700 minus 390. And we want to know what the difference is between those two numbers. But 390 is really close to another 100. What would I need to add to these two numbers to make an easier problem to solve? I can add 10. The difference doesn't change, but my math gets way easier. I have 710 minus 400. 710 minus 400 is 7 minus 4, 300. And then the 10 doesn't change because we're not taking anything there. This is a much easier problem to solve than 700 minus 390, which is going to involve some unbundling and decomposing. This I could almost do in my head. So compensation, where I add the same number to both of the numbers we're subtracting, compensation makes an easier equation to solve. We always want to go with what's easiest, what's most efficient. Now, if compensation doesn't make sense to you, if you don't understand it, it makes you uncomfortable, then it may not be the right strategy for you yet. If you're comfortable with the place value chart and your chips, if that is your most comfortable way, then it might be most efficient for you right now. If you really like the arrow way, that might be the most efficient way for you right now. But the more you become familiar with these other strategies, the more you'll be able to choose which way is easiest to solve. Let's go ahead and turn. I'm so sorry if you were still copying that. You may pause. I'm going to go ahead and turn to page 206. So again, they are offering us an expression 919 minus 657. And they want us to decide what's the best way. What is the easiest way to solve this problem? It doesn't seem to me like there is a quick and easy way. You could probably do the arrow way, but it seems like it would get a little tricky as you tried to get to 919 at the end. So I think the easiest way for me, and you can disagree, is to do the vertical form and the chip model. These numbers aren't particularly close to easier problems to solve. Yes, it's close to 920. That doesn't really make it an easier problem. So I'm just going to use the chip method because it's pretty easy for me. So we have 9 hundreds, 110, and 9 ones. This is the number we're going to take out of that. Can I take 7 away from 9? I absolutely can. I'm going to take 5, 6, 7. And how many are left? 2. Good. So I didn't need to change anything there. But can I take 5 tens from 110? No. Where am I going to get more tens? I'm coming over to the hundreds. I'm going to unbundle or decompose 100 and give myself 10 tens to work with. So now I need to change that over here. I don't have 9 hundreds, I have 8. And I don't have 1 10. I have 10 and 1, which is 11. I can take 5 away from 11. I can take any 5, so I'm just going to take that. And here I have 5 and 1 left. So 11 minus 5 is 6. I have 8 hundreds, and I'm going to take away 6 of them. 5, 6, and there are 2 left. So 919 minus 657 equals 262. Now I have to explain why I did that. So to me, neither number was close, oopsie, was close to an easier number. I thought the chip model would be most efficient. Now, when you're thinking about efficient, a lot of times we just think fast and easy, but we also need to make sure that we're thinking about being accurate. If I were doing the arrow way, I could do that, but it's going to get very tricky when I go to add up my parts. That number is not going to be an easy number I can do in my head. That part is going to get a little bit tricky. So while it might be a little bit faster than drawing my chips, it's not a lot faster, and I have a chance of making more mistakes. So when I think about the most efficient way, for me, I'm thinking about what's easy, what's fast, and what will be most accurate. And for me, in this case, I thought the chip model would be. You might have a different idea, and that's perfectly fine. That's what the lessons this week are all about. What do you feel is the best way to solve? All right? All right. The um the next two are about this other way of thinking about compensation, because up until now, when we do compensation, we've been adding to get to 100, right? For this part that we're taking away. But when we have all zeros in the part we're subtracting from in the whole, it makes it a little bit harder to subtract. So sometimes we might want to think about taking it away. Remember, if we do the same thing to both, the difference doesn't change. So when I have 299 and 185, if I add 1 to both, I get 300 and 186, right? Great. But 300 minus 186 is much harder to solve because I've got all those zeros I'm going to have to decompose and unbundle. 299 minus 185 is much easier to solve. I can't necessarily do it in my head, but there's no unbundling, there's no renaming or decomposing to worry about. So sometimes you want to work the other way. All right, so these two are the same because as long as I add the same to both numbers, the difference doesn't change. I could keep adding out here. As long as it's exactly the same, the difference between the numbers isn't changing. So as long as I add the same to both numbers, the difference doesn't change. Now you can pause and copy that, or you can write it in your own words, but whatever I do to this number, I do to this number, the difference won't change. All right, so we're going to do kind of the opposite now. Instead of thinking of adding 1 to get to an even number, we're going to think about subtracting 1 to get to an easier number. So I'm going to actually take off one. So we had 500, and then we had 278. I'm going to take one away from that, and I'm going to take one away from that. Have I changed the difference? No. The difference is the same whether we have 500 minus 278 or we have 499 minus 277. The difference hasn't changed. But boy, is that an easier problem to solve. 499 minus 277. 9 minus 7 is 9 minus 7 is 4 minus 2 is that fast. I did not have to do this or this where I'm changing my numbers and decomposing and moving numbers around. I just took one away from both of them, and the difference will be the same. Just like if we were adding to each number. We took one away from each, the difference still doesn't change. It's genius. Boys and girls, thanks for working so hard on this. It's good to stretch your mind to think about math in new ways. See you next time.